Yes, a prime number is a number that can only be divided by itself in one. If it's not a prime number, it's a composite number, which means it has multiple factors. It can be multiplied by other things. So let's go on to chapter 5, section 2. It's called the integers and the order of operations. Honestly, this is where the most errors occur. The order of operations, because of the way you were taught in the past and you were forced to memorize a specific way, is usually wrong. So this is where it all falls apart. We begin by natural numbers. We discussed natural numbers last section. What are natural numbers? Right. They're the counting numbers. One, two, three, four, and so on and so forth, all the way to infinity. Then we moved up to whole numbers. Those are the natural numbers plus the number 0. So it's 0, 1, 2, 3, and so on and so forth. Because we can have numbers that are smaller than 0 with the process of subtraction, we know 7 minus 2 is 5. That could fit in these guys. But what if we have 2 minus 7? What do we have there? Two minus 7 is what? Yes. It's going to be 7 minus 2 is 5. So now we have to look at negative numbers. Those are the integers. They include all of the negatives and all of the whole numbers and all the positives. So basically it goes from negative infinity to positive infinity. We can represent these with a number line. Zeros in the middle, and the numbers to the right are positive. The numbers to the left are negative. Is everybody okay plotting numbers on the number line? If it's negative, it's to the left of 0. If it's positive, it's to the right of 0. If it's 0, it's right there. So yeah, so I'm not going to waste your time with that. But we do have to discuss these symbols. What does this one mean? Next one. The third one. Very good. Less than or equal to, because of this line down here. And this one is greater than or equal to. And then that means the last one is what? Equals or equal to. No matter who you ask, if they remember how to read these, they'll have a different way of determining what number is bigger or smaller than another. How do you know this is less than? Okay, yeah, that's a good one. It looks like a left arrow. It's pointing to the left, which is the smaller numbers. Anything to the left is smaller than anything to the right. Anything to the right is larger than anything to the left. And the reason you read these is because you read left to right. This is a statement of itself. It means nothing unless you have numbers in front of it and behind it. What symbol goes there? Right. Basically, it'll always point to the smaller number. How about that one? Very good. We know the positive numbers. Is 3 less than, greater than, or equal to 5? Three is less than 5. Why is it less than 5? Why? How do we know 3 is less than 5? Exactly. That's exactly right. Three is here, 5 is here, and it points to the smaller one. Same way, this one. We have -10, -9, -8, -7, and so on and so forth. -8 is here, -9. Remember, anything to the left is smaller than anything to the right. So -9 is less than -8. Read backwards, it's -8 is greater than -9. You should be able to read them both ways. 3 is less than 5. 5 is greater than 3. Depending on how you read it. So that's a perfect way to say it. If you don't know which is bigger, put a number line. And it always points to the smaller number. The absolute value. I know you all seen it. What does it look like? What does an absolute value look like? You haven't seen it? Okay, that's not a problem. That's absolute value. You've seen it before. Yeah, it's just, again, it's the name. It's a value. It's a single number. So what is the absolute value of 3? Three. What's the absolute value of -5? +5. We'll do a couple more of these until we can see a pattern. What's the absolute value of -2? The absolute value of 10. So what does an absolute value do? Yeah, it pretty much strips the negative sign from inside that value. No matter what number's inside there, strip the positive or negative sign, and it just comes out positive. Why is that? With the absolute value, what it defines the distance of a number from 0. How far a number is from 0. Can a distance ever be negative? For example, from here to Florida, from Dallas to Florida is how many miles? Approximately. Take a shot. So here's Dallas. Let's say 2024. It's a long distance. How about from Dallas to California? How far is that? Let's say that's about the same, because we're almost in the middle of we're halfway through, which is so great about Texas, is no matter where you go, it's practically the same distance. And if we lived in Florida, we have to fly 8 hours to get to California. But here we only have to fly 3 hours, 4 hours. But notice something, from Dallas to Florida and Dallas to California, they're positive numbers. You ever see a negative distance? No, distances are always positive. I mean, even how far is it from Dallas to the moon? 93,000, something, 93 million miles. Something like that. So, but it's straight up. It's neither positive nor negative. So absolute values do that. It's whatever's inside there. You strip the negative signs and just put the number in there. What would this answer be? Three. Because whatever negative signs are inside there are stripped, they're gone. Because you cannot have a negative distance. It's how far is -3 from 0? It's 3 spaces. How about this?
Is it always
Well, no, you have to do it, and this we're talking about later in this chapter is the order of operations. You have to do the operation first. Absolute value. What's the absolute value of -2? 2. This negative is still there. There's your answer. If it's outside, you treat it separately. So it doesn't matter. You don't have the negative thing. It's just you have to do this first. And then bring the negative down. How about this one? Absolute value of 4 minus 7. Why is it 3? Very good. Very good. Because you have to remember, it's an absolute value, a single number. You can't take an equation. You have to work out the equation first. Now, the absolute value of -3 is 3. Very good. Everybody okay with that? So again, the absolute value is simply the distance from 0 to whatever number you have, whatever value you have. Now, the part of math that ruins most grades is this symbol right here. The negative symbol, the minus symbol. That's going to cause the most troubles. You'll forget to put it down. You'll put it somewhere it doesn't belong. So we have to be very careful. So that's what I'm going to show you now. Whenever we do any type of operations, always treat the numbers and the signs separately. So let's do this next part. The next set we're going to talk about the adding, subtracting, multiplying, dividing of integers. Adding integers. Hopefully, thanks to memory cells, calculators haven't corrupted your brain so much you can't do this. I know you can. We can do, what is that going to equal? (12 plus 5 or 5 plus 12 is 17. Does it matter the order I put it in? No, it doesn't. As 5 plus 12 is 17. 12 plus 5 is 17. So it doesn't matter the order you put it in, which is called the commutative property of addition. It says any two numbers added together in any order is going to give you the same answer. Now, how would you prove that 5 plus 12 is 17? How would you use a number line to prove that? Remember a number line. We have 0 in the middle. Anything to the left, is it positive or negative? Negative. Anything to the right is positive. So far, so good. Is 12 positive or negative? So from 0, we go out 12 spaces. That's this one. Now, from here, which direction do we go? Since it says plus, do we go which direction? We go to the right because that's the positive direction. So we go to the right. How many spaces? 5. 1, 2, 3, 4, 5. So it's 13, 14, 15, 16, 17. That's how you'd prove it. That's the way you first learned it in elementary school. That's the way you still do it. I see if you ever use your fingers, That's the same way you do it. So 12, 13, 14, 15, 16, 17. 12 plus 5. I'm not against it. If it works for you, it works for you. If anybody comments about it, tell them to shut up, because if you get the right answer, you get the right answer. So if you have to use your fingers, take off your shoes, use your toes if you have to. So everybody okay with addition of positive numbers? What's that going to give you? -3 minus 5. Let's look at number 9 again. Here's 0. This first one, where is -3 with respect to 0? To the left, because negative numbers are to the left. So we go left, how many spaces? 1, 2, 3. So it's -3 is here. Which direction do we keep on going? To the left. How many spaces? So 1, 2, 3, 4, 5. So -4, -5, -6, -7, -8. So the answer is -8. See, again, the negative, once I threw the negative out there, it changed the way you look at the equation. But there's a simple rule to understand here. Here it is. If the signs are the same, if the signs are the same, take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. This is addition. Add. So if you follow this rule, remember I said earlier, treat the signs and the numbers differently. So the question I'm going to ask you, is this answer going to be positive or negative? The answer is going to be positive. 6 plus 4 is what? 10. So the answer is positive 10. -3 minus 5. They're both the same sign. So is the answer going to be positive or negative? They're both negative. So I take negative. Now add the numbers. 5 plus 3 is 8. There you have it. It changes the way you look at things when you think it this way. -9 minus 6. Again, ask yourself, is the answer going to be positive or negative? Since they're both negative, the answer is negative. 9 plus 6 is 15. So the answer is -15. 10 plus 3. Answer positive or negative? 10 plus 3 is? Does that make it a little bit easier to look at whenever you have opposite signs? The same thing goes with subtraction. Or subtracting integers. Subtracting integers. 8 minus 5 is what? Is it positive or negative? Positive 3. How about negative 2 plus 5? Positive or negative? Positive 3. Negative 9 plus 2. Negative 4 plus 4. 0. So what the procedure here, the rule here is this with subtraction. If the signs are different, if the signs are, that's the reason they call subtraction the difference. The difference between 8 and 5 is 3. The difference between negative 9 and 2 is negative 7. If the signs are different, then take the sign of the larger number and subtract the numbers. So we're going to sign of the larger number and subtract the numbers. Now, when we say subtract the numbers, what we mean here is this. Larger minus smaller. That's what we mean when we say subtract. So let's look at the examples we just did. Look at the two numbers. Okay, first off, they're different signs, aren't they? This one's positive, this one's negative. So I look at the two numbers, 8 and 5. Which one's bigger? 8. And what's the sign of 8? Positive. So the answer is going to be positive. I take that sign. Now I subtract them. 8 minus 5 is 3. So the answer is positive 3. Negative 10 plus 4. What number is bigger? No, just 10 or 4. Don't worry about signs. What number is bigger, 10 or 4? 10's bigger. I didn't say it's signs. I said, look at the numbers, 10 or 4. What's the sign of 10? Since 10's bigger than 4, it's negative. The answer is going to be negative. Now we subtract them. 10 minus 4 is 6. So look at the absolute value of the numbers. Just give me the numbers. Tell me which is bigger. Whatever sign of the bigger number is, that's the sign of the answer. Is the answer going to be positive or negative? Why? Yes, you still have the answer, but I want the answer why. That's more important to me because 20 is bigger than 15. 20 is negative, so the answer is negative. 20 minus 15 is 5. That's how you do subtraction. Treat them both separately. It's a lot less problems. You'll make less mistakes this way. Treat the signs and the numbers differently. Okay, so that's adding and subtracting. What about multiplying integers? Four times three. This is where students start getting derailed. Because of calculators, most of your life in high school, you lost your skills of doing multiplication. 6 times 8. Nine times 7. Nines are one of the easier numbers because you can use your fingers for that. Yeah, hold up your fingers and put down the 7th finger. Now put it toward facing you, towards you. Now put down the 7th finger. Now count what you have up. You have 6 and 3, 63. So 9 times 7 is 63. 9 times 4. Put down your 4th finger. What's the answer? 36. Put down your 4th finger. Your 4th, 1, 2, 3, 4. 36. 9 times 8. Put down your 8th finger. 72. So yes, nines are super easy. So if you think about it, if we look at a multiplication table, multiplying by one's easy. Anybody have trouble with multiplying by 2? No. How about 3? Yeah, a little bit. Some people have trouble with 3. How about 4? 4 is pretty easy because you multiply times 2 and then 2 again. How about 5s? Those are pretty straightforward. 5, 10, 15, 20. 6, 7, and 8, people have trouble with. 9, now you figure out it's easy. So practically half of your numbers are gone for the multiplication table. Now, easiest way of doing multiply by 6, like 8 times 6. That's the same way of doing 8 times 5 plus 1. 6 is 5 plus 1, isn't it? So we have 8 times 5 plus 8 times 1. 8 times 5 is what? 40. 8 times 1. 40 plus 8 is 48. That's the way you could do it in your mind even. Suppose 5s, a lot of people don't have any trouble with. Multiply by 5 and add, let's say if it's 7. 6 times 7. That's the same. 7 is the same thing as 5 plus 2. So 6 times 5 plus 6 times 2. 6 times 5 is what? If you have to go 5, 10, 15, 20, 25, 30, 6 times 2 is 30 plus 12, 42. So basically, I don't want you to use your calculators. Use your calculators only to check your answers before you hit enter. Do the work on pencil paper with your head. Exercise that muscle between your ears. So multiplying integers. How about 42 times 15? How would you do that? Typically, this is the standard way. 5 times 2 is what? 10. So put the 0, carry the 1. 5 times 4 is 20, plus 1 is 21. Yes, finish that one. Now, put a 0. 1 times 2 is 2. 1 times 4 is 4. Add those. 630. That's the standard way people do it. There are other ways. 15 is 10 plus 5. So we do 42 times 10 plus 42 times 5. What is 42 times 10? You don't have to use pencil paper. You can do it in your head. Yeah. Whenever you multiply by 10, 100, whatever, the first number is a 1, right? So that's the number. Just put how many zeros there are after that 1. So 42 times 10 is 42 with 1 0. 42 times 1,000 would be what? 42 with 3 zeros. So when you multiply by tens, hundreds, thousands, 10,000, it's just put how many zeros are back there after it. How about 42 times 5?
Mhm.
5 times 4 is 20 plus 1, 21. So it's now it's much easier and add these two. 0 plus 0 is 0. 2 plus 1 is 3. 4 plus 2 is 6. What would that one be? Yeah, so all we have to do is take this 2, multiply it by 4 is 8. 2 times 5 is 10. And just put that 0 at the end. So whenever your number ends in a 0 that you're multiplying, just put it back behind there. 30 times 50. Now, what is 3 times 5? 15 and 2 zeros. There are so many different shortcuts and ways you could do multiplication that, I mean, just pick the one you like the best. Other than typing in the calculator, hit enter, because all that does is the calculator gets it, not you. So the multiplication, hopefully you can do it. Now the problem comes with signed numbers. With signed numbers. When you're multiplying numbers that have signs, let's say -3 times 4. Again, treat the signs and the numbers separately. Is the answer gonna be positive or negative? Why? Why is it gonna be negative? The rule here is this. Look at the signs. This one's negative, this one's positive. If the signs of the two numbers, if they're the same signs, it'll be positive. If the signs of the two numbers are different, it'll be negative. So a negative times positive is a negative. 3 times 4 is 12. Like I said, treat the signs and the numbers separately. Is the answer going to be positive or negative? Let's try it again. Positive or negative? The answer is going to be negative. Let's see why. How many negative signs do we have? 3. So we have 3 negative signs. Look at the first two. If I have the same signs, that becomes a positive. And I'll bring this one down. So positive times negative is a negative. So that's what happens. But there's an easier way. If you have an even number of negative signs, your answer will be positive. If you have an even number of negative signs in your entire equation that you're multiplying, your answer is going to be positive. If you have an odd number of negative signs, your answer will be negative. So look at it as odd or even. Odd is negative, even's positive. So in our example here, we have 1, 2, 3 negatives. Since it's an odd number, we know the answer is going to be negative. So all you have to do now is just multiply the numbers. 2 times 5 is what? 10. 10 times 3 is 30. 30 times 2, 60. 60 times 2. If you do the signs and the numbers separately, it takes away the stress of it. Because we can all multiply. But if you have to worry about, is it going to be positive or negative each time? No, don't worry about that. Treat it, find if it's going to be, if the answer is going to be positive or negative. Notice there aren't any plus or minus signs between these numbers. These are all multiplied together. So if you have all the same multiplication, it makes it much easier. So far, so good. Let's look at division. Dividing integers. And division. Division is also called a rational number, a fraction, and a couple other names, but these are the most common ones you'll see. The structure is this. You have a numerator on top. You have a denominator on the bottom. The answer is called a quotient. We have different ways of looking at this. When the numerator is bigger than the denominator, if the top number is bigger than the bottom, we call that an improper fraction. If the numerator is less than the denominator, that's called a proper fraction. So is this example proper or improper fraction? It's a proper fraction because the top number is smaller than the bottom. If it's improper, we need to convert it to a mixed number. Everybody knows what a mixed number is? What's a mixed number? A mixed number is just that. It's got an integer and a fraction. Like, for example, 3 1/5. That's a mixed number. It's got an integer and a fraction. And we'll learn how to convert these in a minute. So, is this the answer? No. Why not? You're not done until all factors of the numerator and denominator are canceled or removed. I put that in there for a reason. Factors. What's a factor? So we have, let's look at this. We have 4 over 10. What is 4 made up of? 2 times 2, right? So the factors of 4 are 2 times 2. What are the factors of 10? Two times 5. These are also called prime factors. You can't go any further with them. Now, once you did that, remove anything that's the same. There's your final answer. So when you have fractions, first factor the numbers and remove whatever you can. Whatever is left is your final answer. Go ahead and simplify this one. We'd first start by factoring 36 and 44. What is 36 made up of? What two numbers multiplied to give you 36? What's that? 6 times 6. That's the easiest one. Or you can do 2 times 18, but 6 times 6 is the easiest for 36. What is 6 made up of? 2 times 3. 6 is made up of 2 times 3. So that's as far as we can go. So it's 2 times 2 times 3 times 3. That's what 36 is made up of. 44 is made up of what? 4 times 11. 4 is made up of 2 times 2. So it's made up of 2 times 2 times 11. We factored it as far as you can go. So now what do we do? Cancel. Yeah. What cancel whatever is the same on top and bottom. So the 2's cancel. The 2's cancel. All we have left is 3 times 3 is 9 over 11. There's your answer. Let's look at bigger numbers. 136 over 280. What do you look for in these problems? Like first 136, what do you look for first to factor out? What's the smallest number that fits in there? Did I give you the division sheet last week? Look at those, because we know since this number ends in a 6, it's an even number. What number is it divisible by? It's divisible by 2. How many times does 2 go into 13? 6 times with 1 left over. How many times does 2 go into 16? 8 times. So there's our first number. Now, same thing with 68. It ends in an even number. So we know 2 goes in there. How many times does 2 go into 6? 3 times. 2 goes into 8. 4 times. How about 34? Again, ends in an even number. So I know 2 goes in there. 2 goes into 3 how many times? Once with 1 left over. 2 goes into 14 7 times. And 17 is a prime number. So it's 2, 2, 2, 17. Okay. Because the last digit in the second number ends in a 0, I know that it's the multiple of 10. 10 times 28, like we just talked about. 10 times 28 is 280. So it ends in a 0. We know 10's a factor. What is 10 made up of? 2 and 5. Those are both prime numbers. What's 28 made up of? Yeah, 2, because it ends in an even number. 2 goes into 2 once, 2 goes into 8. And 14 is 2 times 7. So it's 2 times 2 times 2 times 5 times 7. So once we prime factorize it, anything same on top and bottom, just get rid of it with that 2, that pair of 2s. So what we're left with is 17 on top. 5 times 7 is 35. And there's our final answer. We can't go any further. This is the hardest part. This will take you the most part. But once you get this done and you cancel out everything else, whatever you have left is your final answer. Because nothing else can be taken out. So that's okay so far. And the rules of signs, same thing as multiplication. If you have a fraction and you have an even number of negative signs, the answer is positive. If you have an odd number of negative signs, the answer is negative. For example, -4 over 8. Is the answer going to be positive or negative? There's only one negative sign. It's odd. So if you have an odd number, it's what? Negative. I know the answer is going to be negative. So now simplify. 4 is made up of 2 times 2. 8 is made up of 2 times 4. 2 times 2, so it's 2 times 2 times 2. The answer is negative. Those 2's cancel. What do you have left? No. Where is that 2? On the bottom. What goes on top? There's always supposed 2 goes into 2 one time. There's always, if everything cancels, there's always a 1 left over. And since this 2's on the bottom, it's got to stay on the bottom. Is the answer going to be positive or negative? Positive, because we have 2 negative signs. So the answer is going to be positive. We know we have 2 times 2. I know. Can everybody see that 16 is made up of 4 times 4? So we have a 4 on top, 2 4s on the bottom. So our final answer is 1/4. Because these 4s cancel. Or if you don't see that, go, because it'll be 2 times 2 on top, 2 times 2 times 2 times 2 on the bottom. So that's multiplication division of signed numbers. Improper fractions. What are improper fractions? What do they look like? The top number is bigger than the bottom. So since the top number is bigger than the bottom, we know we have an improper fraction. Improper fractions are turned into mixed numbers. So how many times does 5 go into 8? 1 time. How many left over? So there's your mixed number. This number is on the bottom. It will always stay on the bottom. Or you could do it this way. Ever remember that? Doing division this way? So how many times is 5 going to 8? 1 time. 1 times 5 is 5. Subtract them, we get 3. Everybody good so far? Now, this is everything you need. The number on top here is your integer. The number here is your denominator. This number is your numerator. Convert this one. It's an Is it improper? I messed up. It's not improper because the bottom number is bigger than the top. So all you can do here is simplify. What is 15 made up of?
3 times 5. What is 21 made up of? 3 times 7.
Okay, anything cancel?
The 3's can cancel. What we're left with is our final answer. Let's do it the way I should have done it earlier. There.
What do we notice about this equation? The top number is bigger than the bottom. So it's an improper fraction. Since it's improper fraction, we'll do it both ways. I mean, 15 goes in 21 how many times? One time. 1 times 15 is 15. Subtract those. 21 minus 15 is 6. So whatever's on top goes in front. Whatever's on the bottom stays on the bottom. Whatever this is goes on top. Are we finished? No, because these two can be simplified. What is 6 made up of? 2 times 3. And 15? Yeah. 3 times 5. Anything cancel? The 3's. What I'm left with is 1, 2 over 5. There's the final answer. Everybody okay with that so far? So that's, if I give you an improper fraction, you convert it to mixed number. What if I give you a mixed number? How would you convert it to an improper fraction? Mixed number to improper fraction. The one thing we know is this number has to stay on the bottom. Here's the formula for the conversion. You have an integer and a fraction. Multiply A times C and add B. This is the formula. So multiply these two first and then add that one. So it's 2 times 3 plus 1. 2 times 3 is 6. Plus 1 is 7 over 3. And there's your improper fraction. Convert this one.
5 goes on, that one has to stay on the bottom. So it's 4 times 5 plus 3. Four times 5 is 20 plus 3, 23 over 5. You can always check your answer. Let's go from here. How many times is 5 going to 23? 4 times 5 is 20. Subtract those. So it's 4. This is the top number, and that's the bottom number. And sure enough, it's the same. So that's conversion from proper, improper, mixed numbers. What if I had that? What if it was negative? How would you do it? What'd you get? I don't know. You tell me. The question was, is the answer negative? Well, it better be, because if it's negative here and they're equal, it better be negative there. So we know the answer is negative. So do 2 times 7 plus 3 over 7. Just put the negative out in front. Two times 7 is 14. Fourteen plus 3 is 17. Yeah. In other words, just keep the negative out in front. And when you finish, it goes with the top number. With fractions, the negative will go out either in front of the whole thing or with the top number. You never want to have it on the bottom number. If you have it on the bottom number, move it to the top. So any questions about multiplying, dividing, adding, subtracting signed numbers, integers? Okay, what we'll do on Thursday is we'll finish up the section. We have to do exponential numbers, and we have to do order of operations. So we're going to combine all this stuff.